Hey everyone, the topic of this video is environment variables. An important concept in UNIX is the environment, which is composed of a set of environment variables and their current settings. These environment variables have an effect on how exactly the running processes behave. That is achieved by a querying mechanism. Typically, a process, when it needs, queries the value of a certain environment variable. For example, it can check the exact path of the home directory of its user for saving a file into that directory. Or say it may query the value of the temp variable to find out where it can safely store its temporary files. Such common settings that all processes may need to access are kept as environment variables. It's important also to note that the same idea of environment variables also exists in non-UNIX systems, such as Windows, although their names are slightly different. We can see all currently set environment variables using the command env. So for example, here I see a number of variables. This shell variable, for example, it specifies the preferred shell for my user Chilikan. So this is the bash shell, the born again shell. Some of these variables are set by me, some of these are set by the system or with different programs. For example, this user has been set for me when my user was being logged into the system. And this path, it has some certain setting, then some parts of it were added by me. This conda prefix was set by Anaconda when it was installing itself to the system. The current the PVD, the current directory flag, is set by the system again. So parts of it are set by me and parts of it are set by the system or different programs. From the command line, we can change or set the values of environment variables. We can both change the values of existing variables as long as it makes sense. So for example, if I'm going to change the value of one of these existing environment variables, then I should be knowing what I'm doing and it should be something that I'm allowed to. Or I can create a brand new environment variable, for example, for my own usage. Let's, for example, create a new variable that doesn't exist, but one for using in my own scripts. For example, say that this is my command line directory here in my home, and I want to use this long name. I want to give it a shorter name, for example. So something like an alias to this directory. I can set this environment variable using the command export and give a name, for example, cmd dir, and I will make this to be equal to So this is the syntax for defining. This is the name of the environment variable, an equal sign, and then a long string. This can be surrounded by these quotes if there is a blank space character in the string, or if there is not, then these quotes are optional, but I use them in any case as a general habit. So we have now set this environment variable, and if we check with env, we should be able to see it here again, and here it is. Another way of seeing the environment variable's value specifically is to echo it. This time we are going to put a $sign, so like this. So we have displayed the value of this environment variable. In general, when we are defining the variables, we don't use the $, but when we are using it, then we will need to use the $. So this $sign is specific to the usage context of environment variables, and this is an important difference to keep in mind. So now I have defined this environment variable, and for example, I can write a string, a script to use this variable. You are going to see more about this in the forthcoming videos, but here I prepared a small script, say prep.sh, and this is a bash script that I can understand from this initial line. And what it does is getting this file again from the internet and placing it under this directory, part of which I have defined using the environment variable. So this environment variable is going to point to my home directory, and then the command line course directory. Under it, in the weak4 directory, this file is going to be moved to. So I can just go and place my environment variable like this. Because of the $sign, its value will be evaluated and expanded to here, and this part of the string, the rest of the string, is going to be concatenated to this value. So if I go and run my prep.sh, to be able to run it like this, it should include the execute rights. You are going to see more about this, but because of the execute rights, I'm able to run this script like this. And this has downloaded the file and hopefully put it under the command dir and weak4. So maybe you have noticed, if I use this environment variable and then I press a tab, the value of this is already evaluated and expanded to my bash here, and then I can continue writing this. So this was a this dir was an environment variable that I prepared only for myself and my own programs, but there are some pretty standard environment variables. Let's talk a bit about them. One of the most important one that we will also be talking about it is the path environment variable. So the path is a colon separated list of various directories. These directories are the ones that the shell searches when I give it a command. So for example, if I say ls, for lsing it, it must first find where this ls program lives so that it can go and read from there. So we have seen that we can find this ls by which ls. So ls is under the directory root bin, and root bin is one of the directories in path. So when I say ls, the bash shell goes and searches these directories one by one. So does my anaconda /bin has ls? No, it doesn't. And does my usr local bin has ls? No, it doesn't. Does my usr bin has ls? No, it doesn't. Does bin have ls? Yes. So the moment that it has found this file, then it executes this ls. We are going to see more about this path variable. It's really important when we are installing scripts or libraries locally, because we can want to put some local scripts or libraries that are not under the general path setting. So we may want to change this path to include also this local directory. We are going to talk more about this in general. So another important environment variable is home. So we saw upwards, but this is my home environment variable. So because this is defined like this, for example, I'm able to use this home here as I wish. So my home is expanded like this again, and then I can go here. And also programs and scripts have access to this home variable. So for example, if you are writing a script that you don't know where it's going to work in, for example, you are working in your home directory at home and also in Taito, but in any case you want the output file to be saved in the home directory, so you are welcome to use this home variable in your script, and whichever the home is for the current setting, then your file is going to be saved under that home. So this basically makes your scripts more portable. pvd is the working directory. So this is my current working directory, and if I change directory like this, So for example, going to this weak4 directory, and then if I try to echo my pvd, then my pvd will be updated accordingly. This will give exactly the same output with the pvd commands, but then this pvd can also be used in a script, just like home. So if, for example, the script wants to save something um, in this current directory and under some other directories, for example, then it's welcome to use this pvd environment variable. Another variable, let's see if I can find here. Yeah, that one is not here because it's a new computer, so I didn't set up that one yet, I think. But something that we will also be talking about next week is the LD library path variable. So this is an important variable for installing C programs, because on many Unix systems we will need a dynamic linker to add our libraries when we are compiling our programs, and this variable will hold the paths to our libraries. So if you want to add additional libraries to our system, we may need to extend this path with the locations of these new libraries, but we will talk more about this in week 5. So you have been seeing somehow these language related variables, the long and lc all, and in general the lcs. lcxxx, which can be, for example, lcc type or lc time or lc numeric, and similar ones. So these are the local related environment variables. These are used to set the default locales. So in general, the environment variable that you are going to use or set as a user to specify the locale will be long. This is the normal environment variable. And then these extra things like the time or numeric or blah blah, these are the things that are set for overriding long in only one aspect. For example, this environment variable defines how the time information is specifically printed, so the format for the time information. This lc all is used to suppress the long in all these categories. So is in general used, for example, for the configure scripts generated by GNU autoconf to make sure that, say, all the tests run in the same locale, so they don't run in different locales and in general make a mess. So the basic idea is that you set the long, and then these different settings are used by various programs or scripts if they want to suppress this long option for one run, for example, like switch or make sure that everything is running in English, to make sure that everything is in the default settings, for example, to make sure everything is okay. So another interesting variable is ps1. This refers to this prompt in the command line. So for example, if we echo my current ps1, you will here recognize elements that are here. For example, this is the base string, and then this v, this is my working directory at the moment, and then this prompt writing is a fixed string from here. We will talk about this and how you can customize this particular prompt for yourself in the next video. I want to make a small stop here to talk about different shells. So until now we have been working on and talking only about the bash shell or born again shell. So for example, if I echo the value of my shell variable, this is going to give the preferred shell for this user, for my user. So my preferred shell is bin bash, which is the abbreviation of born again shell, as we have been talking about. And when I try to open a shell in this system, because of my preferred shell, I generally open a born shell, and this is like the default mostly these days. So unless you do some specific settings, probably you will be working on a bash shell as well, and that's why we have been working and talking about this mostly. But there are different shells as well, and how to set an environment variable is shell dependent. So in the born again shell, then we use this export variable is equal to value kind of syntax. But if you use different shells, then it's important to check how to exactly set this environment variable. So what kind of different shells exist? Well, one of them is the born shell. That is basically the basic shell, so it is just abbreviated by an S and H. And I can start a born shell from inside my bash, for example, by giving this command. So basically I have asked for a new shell, and this new shell has started now. And well, in a born shell, the way to make this kind of setting is first I set the value to variable, and then I go and export this variable. So this is how I do it in the born shell. I can exit from this shell using my Ctrl D, and I fall back to my previous bash shell. Another version is the corn shell, or KSH. The syntax for the corn shell is the same with the born again shell that we have been using. So in this sense, and I can exit with a Ctrl D. And yet another one is the C shell, or CSH. And in this kind of variable, I will use this set nv command instead of export to set the environment variable. But this is basically of theoretical importance. It's good to keep in mind that different shells exist, but we will mostly be working in bash shell. But if you see this set nv around somewhere in a forum, then keep in mind that this is also for setting the environment variables. So about setting environment variables, there are basically different permanent levels of doing this. So the most basic way of setting a variable, for example, is using this kind of assignment. This is very similar to programming language kind of setting. So I can do just this. But now this setting is made valid only for this current shell, and that's it. If I also export this value, then now this setting is valid for this current shell and also all the processes that are started from my current shell. If I export also the value that I'm assigning to this gmedidir variable, then this will also be available for the other processes. So when I run the script prep sh from the command line, yeah, this was a wrong setting. But if when setting the value of this cmddir, if I also use the export keyword, then basically this value of the environment variable will also be exported to the children of this shell, in which case this process will become a child of this bash. So this will also have access to this directory and will be able to write it there. So this type of setting that we do with export, it is good and working for this shell and for its kids. But if, for example, I open a new shell, say I close this window, and then I open a new shell, and I try to read the value again, we will see that this has gone. Because this kind of export setting is volatile and it's only for the current shell, and as soon as we close the current shell or maybe open a second one with a tab, for example, then the value is not available anymore. So what we do for this, if we want to make a permanent setting, we write it in a file. There are some files that the bash reads every time it's started. So basically we make the setting in a file, and then every time the system is started, it goes and reads from that file. So basically we are doing the setting permanently. So for every bash, the same setting is going to be read and the same setting is going to be found. So we will talk more about this in a second, but one of the most used files is the file that is called bashrc, that is preceded by a dot. This dot makes this file a hidden file. So bashrc, for example, my bashrc lives in my home directory, but I cannot see it with a simple ls, because the ls only shows me the visible files. For seeing the hidden files, I need the flag -a for seeing all files, and this is also going to show me all these hidden files. And this hidden file, the bashrc file, is one of the files that I can record this kind of environment variables. There are other files, and also Mac users, you need to be careful and you need to be using this .bash profile file here instead of bashrc, and I will talk why in a second. So let's say I open this bashrc now very quickly, and I will be talking more about this, but say I add here and export cmddir is equal to users command line course, and I save this file and I exit and close my terminal. And then if I open a terminal and try to echo that variable, then I will be seeing this file, this value. So basically by adding this value to the bashrc, we have made this change permanent. So one thing to keep in mind is when we change the bashrc file, so for example now I want to change this cmddir to also include the week 4, and I will write this, yes, and I will exit. Then if I echo again the cmddir, you see that the change didn't take place immediately. So the change takes place in two conditions. One is when I open a new terminal. Now the change has occurred. So basically every time I open a new bash, the configuration file, the bashrc file, is read and then applied. But if I just have saved the file using nano, then nothing happened here. My bash is still continuing with the initial settings that it read when it was started. So there are two ways of making this bash read that file. One of them is using the source command, and then the source means go and read this file and execute its contents. So after this one, I can check the value again, and now it has changed. The second one is using the bash command, which I more often do habitually. This bash opens up a second bash here. So now my bash, which is going to interpret my commands is a different bash. Here I opened another window. So here, for example, I echo cmd-dir, then this will also give me, well, because of the source is giving me the new result, but even if I didn't do the source here, then it would still give me my new updated value, because I have now opened the second bash inside my first bash using this bash command. And because I'm now working in a second bash here, I can exit from it, and as you see, my terminal window has not closed because I actually fell back to my initial bash here. So let's talk about these configuration files in which you can write the settings for your environment variables. We are going to be talking specifically about bash files, the configuration files that are read by bash shell, because our default shell is the bash, but in general this is not quite the same with all shells. So according to the different shell you are using, you may need to use different configuration files. So maybe not surprisingly, there are abundance of configuration files in the system for setting your environment variables, unfortunately. There are a lot of files really. So one of them is, for example, etc bash rc. We can go on and cat my settings, for example. Another is etc profile. So these are the global files in a sense. Then there are local files that are in my home directory. So these ones start with a dot and are hidden files. So one is my bash rc here. Another is called bash profile. Another is bash login. I don't happen to have this file. I don't need to have all of them. And another one is profile. So you don't have to write in all of these files. Some of these files can be used interchangeably, and basically some of these files are not used. There used to be some conventions historically, such as which kind of information should go into a profile file and which kind of information should go into an RC file, but they are not so rigorously followed anymore. There is basically two distinctions that are important to know. So one is that the files under etc, the etc bash rc file and the etc profile file, well, these hold the global settings. So these settings are valid for every user. So in general, if you want to make a change, then by the UNIX philosophy, it is preferred that we change the local files that start with bash rc, that start with a dot in my home directory. So maybe a lot of files there. So this is one direction that one distinction that is good to keep in mind. The other distinction is more subtle. This is also historical, and it comes from the difference between a login shell and a non-login shell. So the definition is that a login shell is any shell that you use to login the system when you are giving your username and your password. This is typically the case when you are connecting to a remote server using SSH, or for example logging into a computer that doesn't have a graphical user interface. So there is only a terminal and it asks for username and password, and you give them, and then you can you have access to using the command line as your user. In this case, your shell is called a login shell, and if it is a login shell, then it reads the profile files. So first thing a login shell does is reading and executing the etc profile file. This holds, as I said, the global settings for all the users in the system. So basically all the users have access to this file. You will notice that although this is under the root directory, so this is not in my home directory, but I still have read permissions for this file, which makes sense because I want to read and take the settings from this file as a user. So every user has necessary settings for this file. After this file is read, then your shell looks for, first, is there a bash profile file? If not, then is there a bash login file? If not, then is there a dot profile file? And it basically executes the first file that it finds and it's readable. It's completely okay if none of these files exist, by the way. In that case, the shell just skips that step. And after executing this global settings file and the first local file that it finds, then it displays us our prompt. So even before anything is displayed here, when I open a new window, so even before anything is displayed here, all these configuration files are being run, if this is a login shell. A non-login shell, on the other hand, is one that you didn't use to log in the system. So typically, if I start my terminal here from the command line interface, then my terminal is a non-login shell because I didn't use my username and password to open up the shell. In this case, the bash reads the RC file. So it first tries to read this etc bash RC file, and afterwards it tries to read the local bash RC file in my home directory. Again, it's fine if this bash RC file doesn't exist, and it may not exist in a new system, so you may need to create it from scratch, for example, if you want to define some environment variables in this file. So for example, if I did in a second ago, and if I open a new bash within a bash, this is also a non-logging bash because I didn't use this to enter the system. And again, this bash is going to read my etc bash rc basically, and after that my dot bash rc, that is the local file. So why is there such a stupid distinction? That is very historical. So the idea is that basically historically the systems were so slow, so when things were being printed in the screen, that actually was some kind of overhead. So to increase efficiency, the idea was that you would have a main window that you would log into the system, and some other windows that you would work in the system. And in the main window, for example, you would like to get some notifications about some new email or maybe from other programs that are running in the background. So their idea was to support this, and these profile files were thought of only for the login shell, and they would work once only for a session setup. This bash profile is an extension that was brought by the born again shell. So the bash would go and check this bash profile first before profile. So the only bash related settings would be in this bash profile, and all the non-bash related settings would be in this profile, for example. And in the RC files, for example, like the bash RC file, you would put some specific settings that you want to see in each bash. For example, how to set up your prompt. Should it give you your time information, your working directory, your user, your host name? So that kind of information you would put in your RC files. So every time you open a new shell, that would be executed, and in every new terminal you would get these specifically bash related settings. So that was the idea. But this is this is mostly not used at all. We don't have the distinction between a login shell and a non-login shell anymore. It's usually we log into the system using our graphical user interface, and afterwards we just run our terminals. So pretty much almost all terminals are well, similar to each other. So the general suggestion, recommendation these days is you don't worry about these differences. Most of these files are never really used in practice, and for example, you will see that it's super uncommon to see a file like bash login or on any forum or internet comment or something. Uh, Also, the global setting files, the etc bash rc and etc profile, are rarely used since it is the common practice that we set up our own user files when we need to make a change. The most common files that you will be seeing around are bash rc and bash profile, especially the second one from the Mac users around, but you will mostly see referrals to these two files. So the general recommendation is you use one of these files, and from the other file you read that file. So for example, how I set up my bash profile. So if, or for example, I open this with nano. So my bash profile, if there is a file called .bashrc in my home directory, then it reads the configuration from this bashrc file. So basically my bash profile is redirecting me to my bashrc file, and then I put my settings into this bashrc file myself. So now if I open a so-called login shell, my bash profile is going to be read. For example, if I SSH to my computer to a login shell, then the bash profile should be read, and then it's going to redirect me to bashrc, and otherwise my bashrc will be read directly. Well, when I'm saying my bash profile and bashrc, I was talking from the point of view of a standard Linux installation, but not surprisingly, the macOS is an exception again. So the terminal app in macOS runs by default a login shell for each new terminal window. So normally what I would expect in a Linux system when I open a new window, this would be not a login shell, but this is actually a login shell now that we are working on this terminal app in macOS, and what it does is actually to go and read this bash profile file. So if you are working in Mac and if you write your settings in the bashrc file, you will find that they are not being read by default. What Mac reads is this bash profile. So here you have a choice. If you like, you can do as I do and write in the bash profile a kind of redirection to bashrc and then go and write your settings in your bashrc file, or you can go Mac style and omit bashrc completely and just fill in your bash profile file with the exact same things. But it's important to keep in mind, so for example, if you are working in the Taito server or another Linux server, then you will need a bashrc for that because it's a Linux distribution. So for myself, I'm kind of old school. I prefer to have a single file that I like, that I can easily keep and maintain between platforms. So this is how I do. I generally hold my stuff in bashrc, and in general I put a bash profile redirection to that file. So this is it as the introduction to environment variables. I hope these weren't very complicated yet. In the next video, we are going to set up a bashrc file so we can see in practice how things work and what we can do more clearly, what kind of settings we can change.